Automated Podcast.
Welcome to Automated. I'm your host, Mark Verbenkov, and in this weekly podcast, we will be exploring the impact of emerging technology on jobs, society, as well as us, with business and technology leaders, researchers, and independent professionals across the world. So on the podcast, we've already explored blockchain technology and how it might disrupt intermediaries in finance and other industries like real estate in previous episodes. But as blockchain exists within a digital environment, how will cybersecurity issues play a role in the industry's growth? Will private and public blockchains be hampered by an ever-growing need to remain safe? Or is there a way to deal with hacks and overall cybersecurity that provides the security needed for the industry to grow? So my guest, Souhail Mssassi, joins me today to talk about these issues and, of course, the future of cybersecurity in the blockchain space. With more than 8 years of experience in cybersecurity as an offensive security engineer specialized in application security, cryptography, and security of decentralized applications, Souhail assisted several organizations in improving their overall cybersecurity strategy. And as an instructor and a speaker, he presented security lectures in universities and conferences around the world. He's also a blockchain developer in Solidity and Rust, and also working as a security researcher in blockchain with the Quantstamp organization, which delivers end-to-end blockchain solutions for the world's largest enterprises. Great. Well, thank you very much for coming onto the podcast, Souhail. It's great to have you here today to talk about blockchain and cybersecurity and some of the interesting ideas that are coming out in the crypto and blockchain space.
Yeah, I'm very happy, Mark, for the invitation, and hope that the one that are hearing us to understand more about the blockchain industry and also about how to begin a cybersecurity career in the blockchain industry.
Yeah, absolutely. Well, maybe we can just start off with your personal interests. How you got into cybersecurity within the blockchain industry, just so that the audience has a little bit of a sense of kind of like what personally drew you to this space.
Yeah, sure. So basically, I was working in the cybersecurity industry 8 years. So I was a regular pen tester. So I was doing auditing in web application security, mobile security, infrastructure. So basically, my job was to find issues or vulnerabilities in the system, and I did also did some bounties. So basically, I did found some vulnerabilities in Facebook and Yahoo and all other websites. So my job is of course to detect these vulnerabilities before that bad guys or hackers do it, and of course advise the platform or the developers to correct bug. So after of course doing some security and cryptography and all of other IT related stuff. So basically I was doing programming and also some network. 4 years ago, I discovered the blockchain world, and of course the first contact with the blockchain, and I think everyone is knowing this now. It's Bitcoin. So it was the first contact with this technology, and of course Bitcoin is just a little application of the blockchain technology, but at this time it was a revolution at this time. And basically the idea of having a cash financial system that it will be decentralized this way, it was very revolutionary. And of course at this time Bitcoin was only used by hackers, or by, if you want, for example, to buy something from the deep web or dark market. So basically this is the first contact to me to blockchain. But after, of course, I want to also create a token or create my own cryptocurrency. So now I worked at this time, I worked as a Solidity developer. So basically it's like a blockchain developer. And I was, of course, I was discussing with the clients, understanding their needs, how exactly the blockchain technology can help them in their business, how exactly to integrate a blockchain in their business. So I was basically starting my career as a blockchain developer in blockchain, of course. And after this, I was doing also architecture and leading a team of developers in blockchain. And after this, of course, I said to myself that, okay, I have this understanding of cybersecurity. I already have this experience in cybersecurity, and I have this knowledge in blockchain and also blockchain development. So why not use this experience to work in the cybersecurity field in blockchain? So after this, I worked with the top security firms. I worked in Halborn. I worked with audit now in Quantstamp. And basically, our goal is to make sure that each smart contract or each application in the blockchain will be secured, and we will not find any bug or any issues.
Terrific. Thanks. Yeah, let's maybe we're getting ahead of ourselves here, because I think that the audience, I mean, I'm sure as you discuss with many people in the world, I've had discussions with people and they're still not really sure what cryptocurrency or blockchain is. So, I mean, it's really interesting to hear your journey into it, but I think maybe a relevant place to start would be like giving a little bit of a brief overview of cryptocurrency versus blockchain, because I think many people think that they're completely different, or they're completely the same. Maybe you could just kind of set the context for many of the listeners that maybe have no idea about the two differences.
Yes, and it's a very important. What did you mention, Mark? Because a lot of persons mistake with the world of cryptocurrencies or with versus the blockchain world. And basically, just to explain how exactly how it started. So it started, of course, in 2009 with a research paper with a person named Satoshi Nakamoto. So this person was very interested in, of course, after the crisis, he is interested in creating a financial caste system. And of course, before that, it was this concept of cryptocurrencies or virtual electronic currencies, but there is no concept of decentralization or traceability or transparency. So Satoshi Nakamoto has created this, what we call now a consensus, the proof of work consensus, and he launched the first cryptocurrency, it's the Bitcoin. So basically, Bitcoin or Ethereum or any other cryptocurrencies are a virtual currency that they use the blockchain technology to, of course, ensure this kind of transparency and to destroy or to eliminate the third parties or the bank or the intermediates. So we can say that cryptocurrency are a direct application of the blockchain. Now, if we go to the blockchain is the concept, it's the technology. So it's like, for example, we can say internet and a website. So internet, it's the whole concept, the whole technology, but a direct application of internet, it's the web or the website. So the same thing, the blockchain is the concept of the technology. So basically, blockchain, it's a technique or protocol or a concept that will use a shared database between different nodes, and these nodes, of course, will validate all different transactions. So imagine, for example, I don't trust you, Mark, and also you don't trust me. So we should have like a consensus that will ensure that no one will lie to other person, and all other persons also should involve in this process and to have some confidence in the system. Of course, the easy technique or the classical thing here to do is that we will elect someone, and of course, this person, we should trust him. But it's the classical thing. So, for example, when we exchange money, so we have the central bank that will ensure or that will have some confidence. But imagine if I want to communicate with you directly, peer-to-peer transaction, etc. So here it steps the blockchain technology. So blockchain will ensure that each node or each participant in the blockchain network will, of course, execute some transaction, and all the other persons will know this transaction that it is happened, and it's 100%, it's not a fake transaction. So basically, it's a consensus that will ensure that everything is in the block are legit, and of course, we can ensure or see all the different transactions in a transparent way. But from the other hand, the cryptocurrencies are, we can say, we have also, when we are talking about crypto, we have two different things. We have the native currencies, and we have also the concept of tokens. So cryptocurrencies are the native money for using blockchain. So for example, when we are talking about Ethereum network, we are talking about Ether. So Ether is the cryptocurrency that is used in Ethereum. Bitcoin also, we can have Sol for Solana. So we have different cryptocurrencies. But also we have this concept of tokens. So tokens is like a representation of these currencies. So imagine, for example, I can create an asset, or create a paint, or create a music. And this music, of course, it will be represented by a token. And here we are talking about NFTs, non-fungible tokens. And of course, me as a creator, I can ensure that this piece of art that I created, it's fully mine. So I have this ownership, and of course, I can sell it to other people, and also other people can encourage the creator and can send them, for example, Ether to as a credit for his art. So yeah, this is the difference between blockchain and crypto. Crypto are a direct application. It's not the technology or the concept, but the blockchain is the all technology and the all concept that is used in different domains, including cryptocurrencies.
Terrific. I've also heard said that there's now something called like enterprise blockchain versus, say, cryptocurrency, where the enterprise blockchain might be like large corporates or even a consortium of enterprises that are using the blockchain for their own kind of private, for their own private uses. Is that also something that you see, that there are these kind of two camps that exist? You have the cryptocurrency, which are a little bit typical, more open, maybe a little bit more rebellious, versus enterprise blockchain that is used by like larger corporations or consortia of organizations.
Yes. To answer this question, so we should discuss about the blockchain types, or types of blockchain that they exist. So okay, we said that blockchain is a great technology, but of course it has some problems. And imagine that I say to you, Mark, that okay, all the different transactions that you will do, it will be transparent and everyone can see it. So we have this confidentiality problem. So imagine that all the different transactions that you do is open and public. So enterprise or companies are thinking about a way to integrate the blockchain technology, but at the same way protect their critical data. And so of course they cannot use the public blockchain. So here we are discussing about the public blockchain, and we have, in the other hand, the concept of a private blockchain. So basically a private blockchain is it's the same concept, but with some limited nodes. So only authorized persons are allowed to be in this network. And of course, companies now, they are using it to ensure, for example, if we have many banks and these banks doesn't trust each other, they can use this system to, of course, ensure this trust and also this traceability. But of course, it will be only limited and authorized by only these banks or only these entities. But of course, they cannot expose all the different information to a public ledger, like, for example, Ethereum. So yeah, the concept of private blockchain now, it's a very important concept. But of course, there is other persons that they say that private blockchain are not 100% decentralized, because of course blockchain, the main goal of it is this decentralization. So we can have also what we call a hybrid blockchain. So it's a mix between a public and a private. But the main thing that we are now seeing, it's public blockchain with all the different blockchain that we know, Solana, Ethereum, Polygon, etc. And we have also, in the other hand, the private blockchain, like for example, Hyperledger. Now we are seeing companies that they use for their business logic, and also to ensure this privacy or this protection of data.
Perfect. Super. Yeah, it's I think that we have to go down these levels of understanding, as this is an emerging technology. And I think that even though many people, I'm sure everybody listening to the podcast has at least heard of Bitcoin, they might not be super aware of like the different, enterprise or private blockchains versus the public type crypto type projects. But maybe we can move on into how this relates to cybersecurity, right? So if we have these two different types of blockchain, right, private versus public, how does cybersecurity and security in general work in these two different ones, right? You mentioned nodes several different times. So there's, of course, in the public blockchains, you have a decentralized way of securing that blockchain, but not so much in the private blockchain space. So could you touch on like how does cybersecurity work in each of these different modes of blockchain?
Yes, of course. So, of course, before discussing about cybersecurity and blockchain, I will start with discussing about cybersecurity. Now, why we need, of course, cybersecurity. Of course, we need cybersecurity to protect our system from bad guys, from hackers, and especially from black hat hackers, because of course there are different type of hackers. They are what we call the white hat hackers. So there are good people with of course knowing in network security, in security in general, but their goal is to help the platform or the developers to protect their system. And in the other hand, we have also the black hat. Of course, his goal is to steal money, to destroy the system, etc. So our goal as a developer or as cybersecurity engineers, to of course to protect the system or the data. So because of course the main thing here is the data. So of course, if we are a bank, our client data is very important to us. If we are, for example, in a hospital, for example, the patient data is very critical to us. And of course, we see now the importance of cybersecurity, and of course we have now we see now countries are preparing for the cybersecurity war now. Now war, it's not with guns but just with computers. We can see that a great war will begun, and of course we should be prepared for this war. So now we understand that cybersecurity is very important, but how exactly cybersecurity in blockchain work, and also what is the difference between we can say classical cybersecurity in web application and in blockchain. So the first thing to study this, the hacker or the bad guy will have a kind of motivation. So and mainly their motivation is to steal money. And of course, when we are talking about blockchain, you can say, for example, smart contract, DeFi application, decentralized finance application. We can see, for example, some decentralized exchange with some ethers, etc. So, of course, the DApp or the application that are deployed in the blockchain are mainly some financial application or application that have this logic of money. So, of course, instead, for example, of a hacker that he will spend, for example, 10 hours in a classical web application, it can be a social network, it can be other, he can focus 8 hours in a smart contract, and he can steal, for example, $500 million or a very big money. So there is this motivation, there is this financial motivation. This is the first thing. So of course, the blockchain field now, it's very recent. If we are talking about smart contract and Ethereum, so even Ethereum, it's created in 2015, so it's 6 years. So it's not very mature if we compare it to PHP or to websites or to the internet in general. So of course, there is no strict guidelines of how exactly security in blockchain works, because gaining, we are not having this maturity in security in blockchain. But of course, after great hacks, and we will talk, of course, about some great hacks that happens in blockchain. After this great hacks, the developers or the community see a very important need for security in blockchain. And of course, then some companies are created to secure just this part of blockchain. So basically how it works. So blockchain, in the blockchain, we have different layers. So we have the network layer, where we can see all the different nodes discussing with a certain protocol, peer-to-peer protocol, etc. We can see also there is also the layer of the consensus. So remember, we talk about consensus, and each node have agreed to validate this transaction. And also we have this layer, this applicative layer, when we can see the website or a mobile application that will, of course, communicate with the smart contract. And in the last layer, we have the smart contracts when we will have a logic. So just to explain smart contracts are basically are programs like classical programs, but they are deployed in the blockchain. And of course, everything is stored in this ledger, and we can verify and ensure the validity of this transaction. So as a cybersecurity researcher or engineer, of course, you should focus on these different layers. So you cannot just focus on one layer and ignore all the three layers. So of course, you should see all these different layers and protect these layers from bad guys. But basically, what is the important thing and to focus is the last layer about smart contracts. So smart contracts are created by developers, and we know developers are human, so they can do mistakes in the code. It can be in the programming language, or also it can be in the logic of the code. And of course, hackers will exploit this flaw or this vulnerability. So basically, how exactly it works. So after the developer will code this logic of smart contracts, we as a pen tester, we should look into the smart contract line by line, and find if anything is abnormal, or also look for classical vulnerabilities in the smart contracts. And we will do a report of the different finding or the different issues detected by the team, and we will report it to the developers. And of course, they will fix these issues or these bugs. And after correcting this, we do another report to view if they implemented this or if they implemented the remediation well. And of course, we proceed with the final report, including all the different issues that are found and how exactly they correct this bug.
Okay, I do want to get more into smart contracts, because I think that this is something that's quite interesting, and I've heard from a couple of listeners that they're still maybe a little bit unsure about that, about what exactly smart contracts are. But I think maybe we can make this a little bit tangible for the audience. So if we're talking about like the ways in which hackers can break into the different kinds of blockchains, could you maybe give an example or two, maybe some of the larger examples that you've seen of where maybe cryptocurrencies and then also private blockchains have been compromised? Like, where have they actually been hacked, and what has happened?
Yeah, we will discuss about two important attacks that happens in the world of blockchain. So the first one, it was in Ethereum. In the blockchain Ethereum, back to 2015, it was created by Vitalik. So it's a Russian person that created the Ethereum blockchain. And of course, with the Ethereum blockchain, they created also a programming language called Solidity. So it's a very recent language. It's very similar to JavaScript, but of course, as like other programming language, it have some flaws. And of course, here in some smart contracts, they have this problem, what we call a reentrancy attack. So basically, a reentrancy attack, it's a very famous attack that will allow a hacker, of course, to drain money from smart contracts. So imagine, for example, you created a smart contract with your own logic. Imagine, for example, we created a smart contract that will do it will behave like, for example, a marketplace. And for example, I want to give you, for example, an object or some item, and you will give me some ether. So basically here, the smart contracts will act as an intermediate, and it will take the ether from you, and it will take the item from me, and it will swap them. So basically,
and sorry to cut you off, but I think it's important for the listeners to understand, like, this is not done with a human setting the smart contract.
Yeah.
It's an automated process that the smart contract initiates once a certain rule or once a certain conditions are met. Yeah.
Correctly. It's an automatic process that it will execute all the different transactions automatically. So basically, a smart contract have his own balance. So for example, like other persons have their own wallet with a balance of Ether and Bitcoin, the smart contract itself have his own balance. So with this reentrancy attack, a hacker managed to drain all of the money that a contract called the DAO contract. Mm-hmm. And of course, the community, it's the first biggest hack in the Ethereum blockchain. And they are thinking to find a kind of solution, because the problem with blockchain, if we find a bug or if we find a vulnerability, the smart contracts are immutable. And what do I mean by immutable? We cannot change the code. So imagine in the classical development, imagine if I found a vulnerability in a web application, I can report it to the administrator or to the developer. They will fix the bug, deploy it into the production server, and it's done. But in the case of blockchain, we have not so much to do, because the smart contracts are deployed, the code cannot be changed. And this is, of course, this is the principle of blockchain, the immutability. So Vitalik and his team, so the Ethereum Foundation or the Ethereum team, is thinking about what we call the fork. And basically, what is a fork? So I will explain it this way. So when I'm talking about the technology blockchain, we should understand first why we are calling it blockchain. Basically, blockchain is a chain of blocks, and in each block we have different transactions. So, and each block is referencing to the next to the next block. So everything is related with the with these blocks with the chain. Mm-hmm. And basically, a fork is like, for the developers will understand me, it's like using GitHub. So we have different commits, and of course we can have a partial, just not the full block, but we will just start the blockchain another time with a certain block and like erase the future. Mm-hmm. So basically, this is why they use the concept of the fork. And the problem was that there is some persons that they don't want this fork, and there's other communities that they want this fork to happen, because of course a lot of money has been stolen. Mm-hmm. So we see some division. So now we have what we call the Ethereum Classic, and also Ethereum that we know now. So the Ethereum that we know now, it's the after fork, and the Ethereum Classic, it's the one that's with the hack.
So if I could summarize so that I understand properly. So because a certain smart contract was hacked, mm-hmm. There was a large amount, I think it was several million dollars worth of Ethereum that was stolen. And because the blockchain is a continuous immutable set of blocks, then the only way that you could reimburse the people that held that Ethereum was to literally change the blockchain itself. And then you would have two blockchains existing side by side. And I think maybe one thing that's really important to consider here is that, which you stated, it causes a lot of confusion and chaos within the community, within the developing community. the people that are actually working on this. So it's not like in the past where a hacker would steal money from, say, a bank or something like that, and then there would be like one or two clients that would be affected, but it's the entire community that's affected if these blockchains are actually hacked and their kind of security measures are overridden.
Yes, that is correct. And of course, it's very hard to also to control the community. So we have different thoughts, different opinions, and so it's very difficult. And of course, at this time, they are just starting compared now to Ethereum of now. So they had to make this decision to do this fork.
Yeah.
So the problem with the blockchain, it's a simple exploit or a simple program, because just to mention to the audience that what I call the reentrancy attack is basically just if you swap two lines, the problem is fixed. So the problem is in one line, but the impact it's very
massive.
So,
yeah. So I guess in this sense, blockchain is more secure, but it also requires significantly more cybersecurity in order for it to function properly. And if there's a small exploit, then it can cause irreparable harm and damage in the entire blockchain. Is maybe moving on from that, is that also the same thing for the private blockchains, or is there some sort of more robust cybersecurity features when it comes to those?
Yeah, so basically the difference between the public and the private in this example, so they are using other system that Ethereum use. So in Ethereum we used as a programming language Solidity, and in Solidity we have this kind of problems and vulnerabilities. But with using a private blockchain, we can use some classical language. We can use Rust. We can use, for example, Python. We can use different programming language that they are more mature in this kind of security systems. But now we are seeing also public blockchain, like for example, Solana, that they use Rust as a programming language, or they are using also C as a programming language. So the problem now is just with the Ethereum, and of course the Ethereum have a big community, because of course they started in 2015. So there is of course this difference also, private versus public, because the hacker should of course he have this step to understand this private blockchain, and he should have the access to it to find flaws. But of course the public blockchain, he has already this access, so he will focus automatically in the DApp or in the smart contracts. But for private, he should have some kind of private key to be in the network. So it's more difficult from this perspective, from specifically when we are the case of an external person out of the company in his home trying to hack this systems.
Right. So that's why we're seeing the whole cryptocurrency space being maybe a little bit more attractive for, say, I mean, I've heard stories of, Russian hackers and Chinese hackers. It's just an easier way to get in and find those vulnerabilities and then exploit them.
Yes. Basically in blockchain, and specifically in smart contracts, we are calling it the Disneyland for hackers, because it's very easy now to find exploits and earn a lot of money from it.
Right. Yeah, I've also heard it being called the Wild Wild West, because you can easily lose all your gold, or you can get hacked and lose everything quite quickly. Yeah. Okay, super. Maybe then we can back up a little bit and talk a little bit more about smart contracts, because I think that this is something very relevant for the podcast and the themes of automation and jobs. But I think also just as a technology itself, it's quite powerful. So I know that you've already mentioned it, but if you could review that point that you were making, like exactly what is a smart contract, and then we can maybe touch on like the impact that it could have on jobs and the applications of it later on.
Yeah, sure. So before talking about smart contract, we should understand why now we are using the smart contract. And we should find, of course, the problematic or the problem that smart contracts will solve. So imagine, for example, that I create a simple website, and in this website, for example, I say to you that I will, if you give me, for example, $5, and the other person also gave me $5, I will, for example, choose one randomly and send to him $10. So in the classical thing, this logic, it will be on on a server, and it's me, the developer, that I will code this logic. So I can, of course, in the server, because you have no access to the code, I can, of course, not make this process random, and they can choose the winners, for example, and send them automatically this $10. So of course there is a lack of trust here, because I can change the code, I can destroy the server, I can also make modification without you knowing this modification. So here we have this problem. There is no transparency, there is no trust. So we should, of course, use a kind of system to do this kind of logic. And of course, at this time, there was this concept of Bitcoin and proof of work consensus, but Vitalik has imagined how exactly we can create what we call Turing programs in blockchain. And basically, Turing programs are a program or a machine that we can do everything that we want. It's like a classical programming language, and it's named Turing because the mathematician Alan Turing, that of course he was the godfather of this field. So after, of course, imagining a way of how exactly we can take this concept of Bitcoin and enlarge it to a greater concept of programs, now we can say what is exactly a smart contract. So smart contracts, it's a simple code or some sequential instruction that, of course, everyone can see this code. So I can, for example, read this line of code and know exactly what this smart contract will do. This is the first thing. The second thing, because the first thing is very easy, we can make our repo in GitHub public, and no problem. But the second thing, and it's also the difference between classical and blockchain world, are the immutability. So I'm 100% sure that the code that I read this day, it will not be modified or changed or updated with the developer. So the developer or the administrator will not have this power to do this kind of modification. So even after, for example, 10 years, the code will stay the same. So this is the second option. The third characteristic is about transparency. And of course, when I say transparency, I'm talking about transaction. When I'm talking about transaction, it can be financial transactions. So for example, if I send to you, Mark, one Ether, everyone can see it. Of course, not with real names, but what just I will see that this address will send to this other address. And also when I'm saying transaction, I'm also talking about a function call. So just to summarize, smart contract, it's some instruction, some function that I can call directly from my browser or from a mobile application with the wallet, for example, MetaMask. And of course, I can interact with this smart contract. So in this, for example, a simple contract, for example, an ERC20, we can see, for example, the approve function, the transfer function. So I can call the transfer function to send you some tokens. And of course, all the nodes or all the different persons can see that this transaction has passed using some blockchain explorer, and they can verify also the timestamp and verify if this transaction has failed or not. So this kind of logic, of course, you should pay for it. So and this is also a very big difference between classical development and blockchain development. So for example, if I'm browsing Google or Facebook, I don't pay money for each action that I will do. But in the other hand, in smart contracts and in Ethereum, for example, in each function that I will call, I should pay what we call a gas fee. So in each transaction that I will do, I will pay, of course, and this amount of ether that I will send, it will be sent to the miners that will validate the block, and also to the EVM machine. So it's a lot of concept about and incentives to make everyone sure and 100% that they will not cheat the system or validate some fake transaction.
Okay, so maybe we're getting a little bit deeper than what the audience would need here. So maybe to summarize, like a smart contract is kind of an automated task that is initiated once certain conditions are met. Are met, and that this is open for everybody to see, so the code can be validated, so you actually know what exactly is going to happen, right? Whether it's I'm sending you money or you sending me money, like we understand exactly what's happening in the core of it. I think it's relevant to also talk about some of the applications of smart contracts now. So, if I mean, I think the obvious example, which you've already brought up, is transferring money, right? Specifically within the cryptocurrency and the blockchain space, money is the main aspect that, or the main application of smart contracts right now. But from what I've heard, there's also the opportunity for smart contracts to do other things, right? So like, I think some examples of specifically in the future would be like certain applications within law. So certain aspects of, say, a case would be carried out by a smart contract, or even the signing or the release of a real estate, for instance, right? So you would have somebody sign a document, and then the ownership of the house would be transferred from one person to another through a smart contract. Do you have examples of this? Is this still far out in the future, or are there already applications of this being done today?
Yes, there is a lot of direct application in smart contracts, and basically we have different industry that we use the blockchain technology in the business logic. So we can have, for example, the banking system, financial system that are using blockchain and integrate blockchain in the system. And here we are talking about DeFi, decentralized finance. So we can see, for example, the concept of flash loan. So how I can make a loan without collateral. Also some opportunities in trading, in swapping tokens, etc. Now we are seeing DEXs like Uniswap, PancakeSwap, etc. We have also in the field of supply chain, for example, we have this kind of how exactly I can track a product or an item, and it will be transparent. So imagine, for example, we have a product or a supply chain, and this product or this item will travel from different entities. How exactly I can track this item through all the different entities? So we can have, for example, a QR code or a barcode, for example, in this item, and in each entity will, for example, scan the QR code, and it will be stored in the blockchain, and automatically I can see all the different process that are done by this item. Also, we have also other application in the medical care business. So it's very hard now in the US system, the medical care process, and it takes a lot of time to reimburse money, etc., and to see if they are meeting this kind of requirements, etc. So basically, we can automate all this process using smart contracts. So imagine if everyone will have a public address, the doctor also will have a public address, the insurance also will have a wallet, and automatically I can verify that if you are already registered with a particular insurance, should I reimburse you? And of course, with the blockchain system, it will take a minutes to verify all this kind of thing. But in the classical way, it will take days and the days. So and sometimes people are needs money very fast, or they need this kind of verification. Also, we can have what we call microtransaction. So, and you already mentioned, Mark, so about sending transaction. And of course, for example, if I want to send US dollars to other country, for example, it will takes a lot of fees to send money. And of course, we will have also this problem. There is now some countries that they don't have, or some persons in other countries that they don't have bank accounts. So it's very difficult to send them money. So basically using Bitcoin or any other cryptocurrencies, of course, we will have lower fees because there is no intermediate. And of course, everyone with a wallet with a public address can receive money instantly. It's a matter of minutes. But of course, for international transfer, it takes from 3 to 5 days. So it's a very big amount or big delay. So we have also application now, and if you have seen the Meta conference by Mark Zuckerberg, they did talk about NFTs token. So now imagine, for example, I'm a creator and I create a digital art, or in the VR world, I can sell it to other persons as NFTs. So I can be rewarded, of course. Also, you mentioned this in law, for example, real contracts. It can be like automatic programs in the blockchain, like smart contracts. And for example, if these conditions are met, automatically it will be executed and send, for example, money, or send also transfer ownership to others. So there is, of course, a lot of cases in blockchain. There is some cases that now we are seeing it, and of course there is some cases that theoretically it's possible, but it takes some time, of course, to adapt this technology in the system. And now, of course, we are seeing banks. So banks, in the first appearance in Bitcoin, they are very afraid from Bitcoin, from cryptocurrencies. But now we are seeing banks that they are thinking about creating their own cryptocurrencies, and they are thinking about integrating blockchain in their system. So yeah, I think the blockchain is the future. So we should not be afraid from it. And of course, we should adapt this technology very rapidly.
Yeah, I definitely agree with you on that perspective. Maybe we can return to some of the themes within cybersecurity. So, if we're looking at, say, smart contracts and some of the applications that you were just mentioning, to me, it really sounds like some of the kind of like lower level activities within many different types of industries will be automated in a sense through the application, through the use of smart contracts. But if I understand what you're saying when it comes to cybersecurity, there's going to be an increased need for the verification, for the security of a lot of these both public and private blockchains, though of course to a lesser extent. So if I can turn this to kind of the theme of the podcast, which is, the impact on jobs, and correct me if I'm wrong here, but I see that a lot of jobs in the near term future that implement or that use some of these smart contracts or other blockchain applications, that a lot of these kind of like lower level activities will be eliminated, right? The smart contracts could do those things, but then there's going to be an increased need for cybersecurity professionals and experts to make sure that these smart contracts and these blockchain applications are carried out without as you said, the black hat hackers taking care of the fine vulnerabilities in a lot of these in a lot of the lines of code. Is that more or less what you see as well?
Yeah, about the destruction of jobs. So it's if we go back, for example, 100 years, we will find that there was a time at some jobs created, but now we don't see this kind of jobs, and it's totally logic. But of course, when destroying a job, we will create 10 jobs. So we can say that blockchain will destroy some jobs, but at the same time, it will create different job from, for example, the cybersecurity perspective. So we will have this field of security in blockchain. We are creating, for example, this concept of blockchain development. So just 10 years ago, we didn't have this concept of blockchain development. Now we are seeing this. Of course, we will now see also, for example, lawyers now. We have dedicated lawyers that understand the blockchain technology and the regulation in blockchain. Now we have laws about blockchain. So of course we are creating also this job. So we should not just see the negative perspective, but at the same time the technology of the blockchain will create, of course, more than 100 opportunities in trading, in financial systems, in development, in security. So, of course, you see cybersecurity in every technology that has been created. We should, of course, look for the security of the system. It can be electronical system, VR, for example, application, blockchain, web application. So it's very important, of course, to feel secure and safe about the system that we create.
Yep. Fully understand. I see that the time is winding down here a little bit. I do want to go back to the idea of the metaverse that you brought up. I think that's very interesting, especially if we're looking kind of a couple of years down the line. But I do, of course, want to talk about Quantstamp and exactly how the work that that organization and of course, your involvement in it is helping to secure a lot of these blockchain projects. Because I think that that's something that maybe is most evident in the conversation that we're having, right? That yes, these public blockchains are very important. The potential of them are fantastic, but more than anything, the security and the cybersecurity of them is perhaps more important than maybe some people realize. So if you can talk a little bit about the work that you do with Quantstamp, I think that'd be very interesting for the audience.
Yeah, sure. So just to talk about Quantstamp. So Quantstamp have been in the cybersecurity industry for more than 4 years in the blockchain. So it's the top one in the blockchain security. And our goal, of course, is to make the world of blockchain safe and secure. So of course we are working with the top of the clients. So we are working also directly with the blockchain creators, with Solana, with all the different big clients, of course, to secure their system and make the blockchain safe. So we are working also with some DeFi application to secure the system and ensure that their smart contracts are safe. And at the same time, we are believing that we should also create tools and do security research. So we are also each year we are giving talks, conferences, and also doing some scientific research and to analyze the different vulnerabilities that we can find in the blockchain world, and of course tell the community what are the different vulnerabilities to fix these issues and to fix these problems. So now we are working on different tools that will help also the developers to secure their system and their smart contracts. And of course, using these tools it will help also the developers to automate this process of security. So of course, when adding this process of automation, it will help developer more to not make mistakes, of course, in the smart contracts. And of course, we are doing also this kind of logical analysis or audit code that will help the developer also to secure their system. And by understanding, of course, the specification and the logic of the business, and matching and viewing if it matches with the code. So basically, it's a very hard job, of course, to be honest, because imagine, for example, you have a code with more than 5,000 or 10,000 lines of code, and you should look and analyze it line by line. So it's very difficult, but of course, our goal is to make secure the system or the smart contract. So we should, of course, analyze this line by line to tell the client where exactly the different problems and the different issues.
And so, I mean, before we talk a little bit more about the future, do you see that this kind of automated security check will be in place in most of the cryptocurrency or blockchain applications in, say, 10 years' time? Or is it still going to require a lot of manual activities by the cybersecurity professionals?
Yeah, so basically, the human intervention or the manual analysis, I think it will be the main thing. We can see, for example, 10 tools now. For example, we have the web security. We have, it's more than 20 years, and we can see I can show you 100 tools that will secure the web application. But of course, every year we are seeing that Facebook is being hacked, or some persons are finding vulnerabilities in Google, etc. So the human intervention, it's the main thing, because now we are not capable of creating a tool that will understand the business logic and find logical bugs. So it's very difficult. So if we can, for example, create this kind of tools, yes, I can say to you that our job is
it's done.
it's done. Hope not.
Right. So at least 2 years away, right? Awesome. Okay, super clear. Well, maybe as the time is running down, let's touch on the metaverse, right? And meta, because I think that this is, if the examples that are being brought up now are true, this is a big part of the future internet that many people will be interacting through. So what do you think is going to be the most important security or cybersecurity issue when it comes to the metaverse, irrespective of NFTs and the blockchain's interaction in there? Do you think that there will be maybe more privacy issues, like personal data, like biometric issues, or will it be the exchange of money and goods that you'll be able to do, as was proposed by Zuckerberg in his keynote speech? What do you think kind of the main cybersecurity issue in the metaverse will be?
Yes. So now we are seeing a lot of application, metaverse or the VR world, that we can install it in our Oculus or HTC or different devices that will be soon launched. And of course, in each new technology, hackers will definitely look after this kind of vulnerability. So also we have this problem of privacy. So now to use the Oculus, we should connect it directly to our Facebook account. So we see that everything is connected, and of course, if you, for example, your Facebook account is hacked, so it can give the hacker a full access to different services at the same time. And of course, this is just from the perspective of the hacker, but we can also talk about Meta or Facebook, that they will see at the same time my activities on Facebook, my activities on Oculus. So of course, using some big data algorithm, and they can see exactly what I'm doing, understanding what are my preferences, etc. So now we are talking about some privacy issues, and it's of course very, very difficult to trust the system. So for example, if Facebook use blockchain, maybe we can trust it, but I don't think so. So of course, with this new kind of application now, we will see, of course, some use cases, for example, meetings, for example, using VR system. And of course, there is a risk that, for example, a hacker can hack, for example, the system and will access to this meeting and hear, for example, some private or critical data or information, etc. So of course, the future of the metaverse or virtual reality is very promising, but of course we should also look for this the security part of it, because, and also as mentioned by developers in Facebook, they learn from their mistakes, and they will think in the security and privacy from the beginning, because it's very difficult to tackle this problem of security or privacy if you are already begin with a project and you are, for example, already created the system. But if you are thinking from the beginning about the security design, and this is what the concept is called, security by design. So from the beginning of the project, we will think about the privacy, about the security. Also, you can share with the community your thoughts about how exactly do this kind of thing. And of course, here the blockchain can help also to ensure, for example, a sincere voting, to do some kind of election, to know exactly what people want, not what the company will propose.
I think that's a great way to end the discussion here, Souhail. I mean, I couldn't agree further with you that the primacy of security when it comes to securing the metaverse needs to be taken into consideration. I mean, it's important now for the social media platforms that we use, for the banking and financial transactions that we use. But I think when it comes to like a place like the metaverse, where there will be a much more immersive interaction that happens between people in a digital space, the security aspects that need to be implemented are, I don't know, tenfold at times more important than they are in the typical online interactions that we do today. So I couldn't agree further with you. Where can people get a hold of you? I mean, I'll have the Quantstamp website up on the show notes, but if there's a preferred way for people to get a hold of you, to get in touch, follow up, where can people get a hold of you?
Yeah, sure. They can contact me in my website. So it's mssassi.com. I will share with you the link.
Perfect.
And also in my LinkedIn or by email. They can ask me if they have any question about blockchain industry, or about also if they are thinking about migrating to security in blockchain. So they can ask me directly, and with great pleasure I will answer them.
Terrific. Well, I'll have those links up in the show notes, as I mentioned. Thank you very much for coming onto the podcast. It's been, I'm personally a big fan of cryptocurrencies and the blockchain space. So I'm always happy to talk to an expert that clearly knows a little bit more than me and can help elucidate some of the ideas that might be a little bit more, I guess, new or confusing for listeners out there who haven't really dived into the space yet. So thanks a lot for your time and for coming onto the podcast.
Thank you, Mark, for the invitation, and thank you also for the audience that now they are hearing us. And I hope that we share some information in blockchain that will help us in their career, or also understanding the world of blockchain and cryptocurrencies. Thank you.
Perfect. Thank you very much. Well, that's it for this week's episode. Thanks for listening. If you like what you hear and you want to support the podcast and the conversations here, the best way to do this is to go onto Apple Podcasts and leave a review, as it helps the algorithm to reach out to new listeners and brings the show to them. Also, feel free to check out the website, automatedpodcast.org, where you can find the show notes for each episode, written articles on the themes of the podcast, and a library of resources on the topic of emerging tech and automation. Also, if you want to reach out and leave any feedback, or you have any questions about the podcast or any of the conversations, there are general contact links such as email, LinkedIn, Twitter, etc. for you there on the website. And finally, for those of you that want more than just an audio conversation, the video recordings are now going to be up on YouTube for the newer conversations, so feel free to check out the videos by searching for Automated Podcast on YouTube, where of course you can like and subscribe if you prefer to support the podcast that way.
The Automated Podcast.